When people talk about blockchain, one of the terms that they will talk about is smart contract. The term smart contract was coined by an American computer scientist and cryptographer, Nick Szabo, in 1994. Smart contract works in a similar way as conventional contracts do, which is to bind parties involved in an agreement to the agreement's terms and conditions. Contracts are important in human transactions to build trust between the buyer and the seller, in order to make sure that none of them will cheat or steal from one another. The only difference is smart contract is a specific terminology used in blockchain transactions. Instead of manifesting as a legal document or stamp duty, the smart contract manifests itself as a codes programmed into the blockchain and thus are distributed across the peer-to-peer network. So, smart contracts seek to maintain trust among parties involved in the blockchain transactions. The smart contract runs on an if-then logic to automate transactions in the blockchain. For example, if the buyer managed to complete the payment within one time 24 hours after the booking, then the seller will shift the object's ownership status to the buyer. This is why Nick Szabo uses the vending machine as an analogy to how smart contracts work. The vending machine will give you the drink or snack you need based on the amount of money you put into it. Yet, smart contracts also have limitations in terms of application and security. Smart contracts have even caused controversies. Finally, the general public has lots of misunderstandings about what smart contracts are and how they work. So, in this episode, I will talk to Blockchain Zoo CEO Roberto Capodieci, who will help us understand more about smart contracts, what they are not, and how they work. So, good morning, Roberto.
Good morning.
Yeah, so my first question is, what kinds of contracts are smart contract and are they smart?
Right. The first important clarification is that smart contracts are not contracts. So it's not like sitting at the lawyer writing down a contract or sitting at the notary and signing a contract. Smart contracts are applications, are pieces of code. At the beginning were called smart money, meaning that out of cryptocurrency, where I can just transact between two accounts a certain amount, with a smart contract I can add a little bit of logic of this transaction. So I can say make the transaction if a particular condition apply. But being code, it can become much more complex. It can actually allow to do more complex things. The first evolution has been the capacity to create additional cryptocurrency on top of a blockchain that has already its own, the famous token that people start using for ICO. And then regulate how this token can circulate, if they can move up to a certain date, etc., etc. So it's absolutely been an incredible innovation in the attempt to decentralize application, and it brought a big revolution in how people use blockchain.
Okay, so how does the if-then algorithm work?
The smart contracts run on what is called a virtual machine, which means it's an emulation of a computer that runs on a computer with a set kind of instructions. There are different languages that people can use to write high-level, let's say, programmer understandable code that it get compiled for the virtual machine, for the emulated computer. So in a peer-to-peer network, each node has this emulated computer inside, and when somebody wants to write a smart contract, need to use a tool that works off-chain, where people create a smart contract, test it, and then is recorded in the blockchain as a transaction. So it's posted in the blockchain with a transaction, all the nodes saves it in a block, and then with another transaction people can call this application, passing some parameters and executing the code. It's like running an application, a small command line application on our computer, but this is done in each node. and the result should be the same for each node, and the result creates some changes in a database, in whatever it is. If it is a token, for example, I transfer some of my token to somebody else, the smart contract has its own database with all the owners of this token, and when I make the transaction based on the rule of the smart contract, the database is updated with the new balances for the people involved in the transaction.
Oh, okay. So you mentioned that smart contracts can be used to create new cryptocurrencies. Do you have any examples?
Yeah, all the token using the ICOs, for example, also the one that are used as a stable coin, USDT, USDC, rather than many other tokens that are well-known, wrapped other currency, wrapped Bitcoin, etc., etc. Those are all regulated with the smart contract in the Ethereum blockchain, most of all, because it's important to understand that Ethereum has been the birth of the smart contract, even though it's being preceded by other blockchain like NXT that could do logic on transaction, even though could not deploy smart contract at the time. But many other clones of Ethereum are now available to run a smart contract, because smart contract has some issues. There are several issues with smart contracts.
Okay, yeah, with the issues with smart contracts, we will get to that topic later. But then, like now, I want to ask you, like, what are the importance of tokens in smart contracts?
That's a utility. Obviously, smart contract is a means, it's not a goal, right? The smart contract is an application. So based on what the application need to do, there are the functionalities. If a smart contract is there just to save user information or whatever, it's gonna have no tokens involved, just as record user information and update user information. The token is powerful because it's the possibility for anybody to create cryptocurrency, a coffee card, whatever it is, and distribute it among users. But it's just one of the applications of the smart contracts.
Oh, okay. So how do we conduct transaction using smart contract? Do you have like one concrete example?
Yeah, to the final user, sometimes this is really an invisible thing. Transactions that imply smart contract are done by pointing to the smart contract address. So when the developer deploys the smart contract in the blockchain, the smart contract earns its own address. And to this address, I can post a transaction, the point, choose the smart contract, choose some parameters. For example, if a smart contract is regulating a token, I'm gonna put as parameter I want to send to the account and the amount, and then that is make the smart contract execute the function following this logic. I'm authorized to do the transfer, do I have the balance, etc., etc.
Okay, and what is the role of smart contract in decentralized finance?
Yeah, that's a beautiful evolution of this smart money, right? Because the smart contracts are application on their own. People start making a more complex application, and they start doing something that is powerful. So they start emulating what is usual bank services in a decentralized manner, so regulated by smart contracts. For example, this is not decentralized finance, but one of the first interesting smart contract was the crowdfunding smart contract DAO. So people would deposit their currency, people has a project, people vote, and the smart contract finance the application, and automatically then the revenue is distributed and so on and so forth. That this is a very complex logic. In decentralized finance, the most interesting things that came up are the stable coin, so the possibility to create a token that emulates the value of fiat currency. So for example, if I create a token that emulates the value of the US dollars, I need to make sure that in the exchanges this value is always fixed to $1. So even though the token is a currency on its own, if demand and offer, there must be a lot of market making application robots. They're called small automated application that always buy or sell the currency, so that is always $1 of value. And evolution to this has been the fact that people can provide liquidity for this smart contract, earning an interest. So if somebody borrow some USD, let's say as a stable coin to make a purchase, can leave as guarantee their own cryptocurrency, let's say Ethereum, make a loan and then repay back the loan with the interest, and people that provide the liquidity earn part of this interest or the full amount of the interest. And this is pretty much remove from the banking system a very important functionality, that is the one to give loans to people. And this is done without signing form, filling in nothing, because it's all based on a smart contract application, and so that's secure for everybody.
Okay. And why is Ethereum the leading smart contract platform now?
It's losing this position at the moment because the fees cost are getting too high. But Ethereum has been the blockchain that started this smart contract, has a huge amount of liquidity, means that a lot of people own Ethereum coins. So if I make a very interesting smart contract that require moving money in a blockchain where people has no balances, has no accounts, then obviously it's gonna fail, right? If I do it in Ethereum where there are millions, if not billions of dollars circulating worth of Ethereum, then obviously my smart contract is gonna find the audience that it deserves.
Okay. Yeah, because it has like a large user base, I think. Yeah,
correct. Yes, user base, yes, people with the account, with money. So.
Yeah, and then like up till 2020, there's a data that there has been, the Ethereum has deployed up to 1.5 million smart contracts. Till 2020. So why is there an increase in smart contract deployment?
It's easier and easier to make them. Many times because once you deploy a contract, you cannot edit the code, you cannot debug it. So it's final every time it's posted. The smart contract that have issue need to be redeployed. So most of the time, each functioning working smart contract has a trailback of several previous deployments. So the number can be a little bit misleading, as in there are not so many amount of smart contract daily used by people. Deployed, yes, I mean it is just a matter of paying the deployment fee.
Okay. Yeah. And how would the L2 Ethereum impact the smart contract market?
How the
L2 Ethereum?
Layer 2.
Oh, layer 2. Yeah.
Sorry, I was.
Yeah.
Layer 2 is a very important aspect. So, what is a layer 2? A layer 2 solution is a solution built on top of an existing platform. So, as a blockchain, once it's deployed, has a lot of dependency on all the node running, all the stability that has been created. It's very hard to upgrade the code in a very drastic manner. It creates huge forks, means that not all the nodes are updated at the same time, so some nodes remains behind. And sometimes solution that should be implemented at the core level, at the bottom level, can't be implemented. So solution at the layer 2 are an alternative possibility to solve some problem. Classical problem are the scaling, the fee cost, because we're talking about $100+ just to change a piece of data in a smart contract. So it's cheaper to transfer money with a bank than transfer USDT with Ethereum at the moment. And in this way, leaving a deposit on layer 0, so on the classic blockchain, there is a way to create this value in a layer 2 blockchain. So you guarantee the value in the layer 2 blockchain with the deposit on the layer 0. And layer 2 blockchain can run on a new technology like Plasma, which allow off-chain transactions, and they are super fast and they are way more cheap. For example, a smart contract deployed on Ethereum can cost $100 per transaction for an NFT, while if it's deployed on Matic, it can cost like 2 cents. So that's the difference, which is radical.
Okay. So what kinds of abilities that a programmer or developer needs in order to create a smart contract?
Coding smart contract is not complex. The code is quite simple. And this is a little bit of a trap because conceptual error are a disaster in smart contracts. Why? Because once the smart contract is deployed, its managing money cannot be controlled by the developer anymore. If there are bugs in the code that can be gained to transfer the funds that are in the smart contract, people can steal the funds. And this has happened many times. The first big event in this case was the DAO, the decentralized autonomous organization, where there were about $150 million worth of Ethereum, and this was made by a company in Germany, I think. The logic to withdraw, so people could deposit funds, and then when they wanted, they could withdraw it back. The logic to withdraw was this: first, check if there is the balance, then send the funds to the person who wants to withdraw, and only after this, change the balance in the database. And people realize that they can make a call to the transfer before the database was updated. So I can deposit $1,000 and withdraw this $1,000 1,000 times, emptying in effect the funds of the smart contract. And when this thing has been deployed, people were just sitting and looking at that. The only white hat hackers that are stealing as well to return the funds to the legitimate owners, but there is no way that you can stop a running smart contract, which is one of the advantages of the smart contract as well, because once that's the code, I know that nobody can compromise the code or change the code.
Yeah. So the next question is, can smart contracts be coded to the DecBC blockchain?
In the evolution of the centralized application, while smart contracts have created a fantastic precedent, a huge trend, and a very important possibility for people to understand the capacity of a blockchain, they're limited in the amount of operation that can be executed. And also in the way that the fee are calculated. So, for example, a smart contract cannot do graphics elaboration. For example, I cannot have a smart contract to add a watermark to an image or to validate make voice recognition. There are a lot of functionality that a smart contract cannot do because the capacity of the virtual machine is limited. The evolution of the centralized application required the possibility for a blockchain to run a more complex application. The take that we have with DecBC is to allow virtual machine to be deployed on not all but a subset of nodes of the blockchain. And this is a very light Linux deployment in a total isolated sandbox virtual machine. And so people can do decentralized applications. So people can write application in C, in Python, in whatever they want, compile it. They are executed in this sandbox's machine. And there are just a limited set of communication with the rest of the blockchain to allow the blockchain to validate the transaction. So at this point, people can deploy transaction that require, for example, analysis, OCR, analysis of text, validation of whatever it is. And the main transaction is validated by the full blockchain, but the subset of nodes that can execute their application receive the payload, make their elaboration, have a subset of consensus that then is reported on the top blockchain. And this will allow to create applications such as web hosting or for example deploying a website require a database, require a lot of things, but if I want to do it decentralized, I need to have a decentralized database, which smart contract can do obviously, but as to run particular set of query, I need to have a data storage decentralized, I need to have computational power decentralized. So all these things allow to create a decentralized application that is actually really fully decentralized, and this will bring us to one next level of decentralizing application. So smart contract is great, is a starting point, but what we need is a more solid and functional system.
Yeah, and you mentioned the DAO hacking incident in 2018, where they lost, I think, 70 million US dollar.
Yeah, about that, yes.
Oh, yeah, or 6 million.
Yeah.
6 million ether. So, like, what the programmers can do in order to prevent such hacking or breaching from happening?
Nothing. That's the point. This is what I was saying. Coding smart contract is simple, meaning that it's not a complex coding system. And this, unfortunately, has the downside that anybody can do those smart contracts. But a developer that can see these small potential loopholes is a very good developer. And then to make a smart contract that is very secure, you require a lot of test debugging, deployment in a beta test, and it's never possible to prevent these things to happen, because just think about this: if there is a malicious actor and he discovers a flaw on a smart contract that is going to manage millions of dollars, and he knows how to steal the money, if he's an honest person, he's going to inform the developers. If he's a malicious person, he's not going to say anything, waits that the smart contract is loaded with money and then steal them, right?
Oh, yes.
So it's also harder to get support by the community to validate smart contracts that are financial, most of all. There are companies that give you certifications, but those are made by humans. There is no system that can guarantee the bugs are not there.
Oh, yeah.
In fact, even companies that do certifications, their own smart contract are hacked. Not all, but some. Obviously, is impossible to say in a definite way that it's not possible to hack a smart contract. So that's one big downside of smart contract, for example.
Yeah, are there some advances in which, like, the developers or the programmers are enhancing the complexity, or like just to make it more secure?
There is something that some developers do. They use what is called a gateway smart contract. So because smart contracts can call each other, so I can have a smart contract they use as a dependency another smart contract code. So I can use one address for my smart contract, but this address is only redirecting the code to another smart contract. So in case the smart contract has a bug, I would deploy the code fixed in a new smart contract and change the address that my gateway smart contract points to the new code. But in this way, obviously, you lose what is the beautiful thing of a smart contract, is the fact that the code cannot change. Because if we are doing, let's say, a work where the smart contract is critically important that the code is that in order to guarantee that the result is A rather than B, and is A or B advantage somebody, if the code changes, the code can be changed to make the result to be what is my advantage, that is B, right? So obviously smart contracts that work through a gateway are not to be trusted as much as a smart contract that is once deployed and will never change.
Okay. So another weakness of the smart contract is the absolute nature of. Yeah,
That's
you have
exactly
mentioned
the point.
that. Yeah.
Code cannot be changed. If can be changed, then you lose the fact that you can trust the smart contract.
Okay.
So, in an ideal world, there should be phases. So people should be able to deploy a smart contract, and the smart contract will be in beta version. Let's say the smart contract can be used, bug can be found, can be updated until it goes in alpha, and after a certain point, the developer can bring into production, locking it.
Oh, okay.
So in this way, we'll give the smart contract a little bit of a lifespan to become solid. This can be done by using the smart contract on a testnet, but it's not the same thing to actually let people use it for real in the mainnet. So, and the negative thing is that once I deploy a smart contract, I cannot stop it from running unless I create a function that lock it. But if people is using it and then I need to tell everybody, no, now use the new one, it's a little bit complex. What we want to do with the DecBC, the centralized application, is really to give a life cycle to the application where there are alpha version, beta version, there is the possibility to debug, and then the application is locked and can be only forked later.
Okay, and because the smart contracts are set in stone, I think it limits the application, right? They can only be applicable to certain transaction.
I mean, what the smart contract can do will do once there is saved, the code is fixed. The things they can do are limited to the capacity of the virtual machine and the maximum amount of gas, what is the calculation of the cycle this virtual machine can do, so that people don't crash nodes. If I can make a smart contract that bring a computer processor to craziness, I would automatically deploy the smart contract, make a transaction that goes smart contract, and the blockchain is gonna go down. So to protect this, they make first the person that executes the smart contract pay for all the processing that the smart contract requires, and limit the amount of processing that can be used to execute a smart contract. This has also been the cause for people to lose money in the past, because an update on the virtual machine in Ethereum causes some smart contract to stop working, because at a certain point the processing became higher because of some instruction that changed, and it was above the gas limit, and the smart contract wasn't accessible anymore. I think it lost about $50 million US worth of Ethereum.
Okay, and then do you have like any examples of what happened when there's a coding mistake in the?
I think the DAO is one of the most classic examples, and is sad because he also pushed the community with the leadership of Vitalik to roll back the Ethereum blockchain. This is the moment where Ethereum Classic was born. Ethereum Classic are the owner of nodes that refused to update their node with the software that was removing the deployment of the contract, right? While the majority changed the code, so the DAO ended up to never being deployed. So they changed the past, which is a very bad things for a blockchain. Blockchain should be not possible to change the past. That's the big advantage. Ethereum shown that they are able to change the past.
Yeah, and then another like issue with the smart contracts is the privacy of the data or the contracts, because like everyone in the peer-to-peer network can see.
Absolutely. This is necessary in order to guarantee the execution of the smart contract, right? But in fact, many banks have copyright on their processes. So So one of the limits for banks to deploy their processes on a public blockchain is the fact that they patent the process and they cannot deploy in a way that people see or use without permission. So they are locked either in making a private blockchain where they only see what they do. At this point they can use a central server because it makes no difference. Or they are forced to publish publicly the logic of their system. With the DecBC, the possibility to have subset of nodes that run a specific application allow also the possibility to encrypt the data that are the payload that need to be run by this application, deploy the application only for the party that agree with the legal contract to run the data, and maintain full privacy on the processes of the decentralized application, which is a very powerful thing compared to a public forceful exposure like a smart contract that runs in every node of the blockchain.
Okay. So what are some of the misunderstandings that people have about smart contracts? I mean, the most popular or pervasive?
Is thinking that they are contracts.
Oh, okay.
So people think that you write the contract like renting a house from the date such, I'm gonna rent the house located in the address such for this amount per month. That's not what a smart contract is. Smart contract is a mere code. Is logic.
Okay.
So that's the most common misunderstanding. They are called contracts, but it's actually applications on a blockchain, right?
Oh, okay. Yeah, so they're not like a physical, like the verbal contracts that
Absolutely,
we use, like.
No, but not even a non-verbal contract. They are just applications that need to be coded to do whatever people want. I can code them to do what a contract would do, but that's just one of the choices I can have. It doesn't have to be like that.
Oh, okay.
So the word contract is highly misleading.
But then, like, what's the association? What's the relation between smart contract and automation? Like, do smart contracts automate transactions?
Absolutely, the automation is exactly the powerful thing. So the application is always there, and when you call it, executes itself, right? And they can be called from other smart contract too, created a chain of executions. The smart contract at the moment that I am aware of cannot be triggered by events. So I cannot say execute this smart contract when this happens in the blockchain. There must be somebody calling the smart contract and executing it. In fact, there are centralized servers that you pay a fee for them to call the smart contract once every certain amount of time in order to create a sort of automation. But smart contracts are not automatically triggered by events at the current time that I'm aware, probably in evolution of the blockchain. In NXT, for example, the logic that can be attached to transaction can be automatically triggered by events. In DecBC and ZooBC, events can trigger transaction as well. But smart contract in Ethereum cannot at the moment. Maybe I missed the note and they can do this now. I knew, for example, in the past the big issue with smart contract is that the person calling the smart contract need to pay for the gas, for the fee, for the contract execution. This was limiting a lot of deployment of tools where people can just use something without having to have a balance to pay. And they were planning to allow the smart contract to pay by itself, to have a balance that allow people to execute to let the smart contract pay for the fee. But I never see it applied. So I don't know if it was just an idea or something that has been deployed. Consider that Ethereum, as many other blockchains that use smart contracts, are in constant evolution and they are implementing new functionality almost on a daily basis. So many things may be there today that I'm not aware of.
Okay. I think another question is another limitation of smart contracts is their limited capacity, both in terms of speed and also size of transactions. So which I think pale in comparison with the like centralized transactions, financial systems.
Yeah, but obviously a smart contract has limit what the blockchain has as limit. So inherits those limits from the blockchain. It's not the smart contract by itself that has limits.
Oh yeah,
It's
yeah.
the fact that the blockchain has limits. So each block has a certain maximum amount of data they can hold. So a smart contract to execute a function never can have a payload bigger than a block, or what is the limit for the transaction. And there is limits imposed by gas just because there are many executions to happen every new block. So there are a lot of limitations, mostly imposed by the infrastructure than by the smart contract itself, and limits that are willingly put to avoid the disaster. I think probably this is the list of the problem in terms of scalability once the technology allowed to do more. The problems are more related, in my opinion, to the limitation in the security of the execution of the smart contract.
Okay. So yeah, I think I have asked all my questions. Do you have anything else to say? Before
Well,
we conclude?
one small observation I have is that the smart contract, for as amazing they are and for as many incredible things they have brought into the blockchain world, they also have stopped developers to dig down to the bottom layer of a blockchain. There is so much money to be made in coding smart contract that a lot of developers, when they approach blockchain, they see smart contract and they stop there. But smart contracts are a high level kind of coding when it comes to blockchain. It doesn't affect how the blockchain actually works. So very few people go dig and understand how to code consensus mechanics, how to code transaction types at the bottom layer of a blockchain. This is also one of the things that have slowed down the evolution of a blockchain, very few. So, and it's also less impactful. So developers that make a new bottom layer technology, it's like creating a new engine for a car that looks exactly like the previous car. Very few people will understand. Maybe somebody creating a new body for an existing engine sell much more because people look at the shape of the body of the car. So there are two factors that limit the evolution of the blockchain, which now is being adopted for many other things except, beside the finance, to create blockchain that are strong and stable for the evolution of the technology for decentralization. So I do believe that there is the need of supporting also the technology that brings, new systems that are not just then new DeFi applications, right?
Okay. Yeah, so that's all for our discussion today on the topic of smart contracts. So thank you for joining us. And don't forget to subscribe to our YouTube channel, Blockchain Zoo. And if you would like to suggest a topic or ask questions, please leave a comment below. And you can also contact us through our website. So see you again soon.